Hello everyone, hope you all are doing well. In today's video, we will be solving our blind series 20th question, which is word break. And I personally think it's a very good question, which is of string and as well as DP. So let's read the problem statement. We are given a string S and a dictionary of string verdict. Return true if S can be segmented into space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. So the problem is pretty straightforward. Like it says that we have given a string, okay, and what we have to do is we have to partition, or you can say segment it into parts in such a way those parts, those string which we partition should be contained in this list of string which is verdict. Okay, let's take this as an example. Like in this we have given a string which is lead code and it partition it from here this point. Okay, it partition it from this point and make two strings. One is lead and the other is code, and you can see that this lead and code both partition, after partition this both string are actually present in this list. Okay, like lead is also present and code is also present. So we can say that this string which is given to us can be partitioned in a way that the partition strings are actually in this list. Okay, so we return true. And let's see here. Okay, and if we consider this example, in this we have given string cats and dog, and there is no way that we can partition this string so that the partition the all the partition string is present in this list. Okay, verdict. Like we can see, let's say if I do cat, okay, let's partition one cat, one string as cat. Okay, the other is sand. Okay, I get sand also. I get the sand also. Okay, then the rest is OG, but I can't find the OG in this list. And if I try for cats, okay, then the other is and. Okay, I find and also. Then again, I can't find OG here. So there is no way that I can partition this string into parts that all the parts that I have created by partition is present in this dictionary. As in this case, you can't find OG here in this list. Okay, so we return false here. So let's discuss this problem. How can we reach to the solution in a broad way? Okay, first of all, let's discuss the brute force solution. So let's take this string as example, which is WeCode, and this list, which is same as verdict in the question. And as you can see, if you directly see this string, you can see that it can be partitioned actually. This V code and club. But let's see how can we do it actually with the help of with coding. So what I do is what I simply take each and every character and I will try to explore its substring. Okay, I will try to explore its substring and I check whether that substring which is created from that particular character which I choose previously is actually present in the list or not. Let's say for example I choose O. Okay, I choose O, then I will try to create its substring. Okay, like let's say O, whether it O is present in the list, whether OD is present, whether ODE present, whether ODEC present. Okay, like this I will try to create substring from here, but initially I will start from W. Okay, WE, WEC, then WEO. Okay, but let's say if I start from O, okay, then I know that if I start from O, so I know that WEC, like the previous string before O, should be present in the list. Then only I can start from O. Okay, then only I will choose O as a character and I will try to make it substring. If and only if I am guaranteed to know that the WEC, which is its previous string, which can be parted before and is present in the list, it can be in the partition way or can be the whole. But I mean it can be WEC in the list. WEC may be present in the list, or it can be present in a way W and then EC, but it should be in the list. Okay, whether it is in the partition way or whether it is in it is as a whole in the string. Okay, So this is all about this. Let's try to dry run it. Like first of all, I start from W. Okay, I will consider W always from the zeroth index. Okay, so it is actually I start from the zeroth index. Okay, I will consider W, and now I will check whether W is present in the list or not. As you can see, the W is not present in the list. I will see whether W is string. Okay, I will check whether I will consider this as a string for now. Okay, because I partition it as, like you can say, I will partition it as W. Okay, I will partition it as like this. Okay, so W is one part and ECODE is another part. Okay, now I will check whether this W is present in this list. Okay, it's not present in this list, so I will not move forward. Okay, now I will add WE. Okay, now the partition is actually look like this. Okay, WE and the code club is another string, and this W is another string. You can say substring. Okay, now I see that is actually present in the list. Okay, now I find that E is present in the list, so I will partition it. Okay, now I will move forward. I will use recursion and call for the next character. Okay, now you can see here. Okay, now I will call for C. Okay, now I know, like at that time I start from O, then I check for OD, EC, and I say that I am guaranteed. I know that if I start from O, so I know that the WEC should be present in my list. And now if I start from C, okay, I will consider now C. Here I consider W initially, okay, and I see that W is actually present in the list. So what I do is I will call, I will recur my function and I will call the same. Like here I call for zeroth index. Now I will call for C, which is second index, and I will do the same process. Okay, and I am guaranteed to know if I start from C, so the WE should be present in the list, and it is true. The W is actually present in the list. So now I start from C. Now I will check whether C is present in the list. No. Then I will go for O. Whether CO present? No. So whether COD present? No. CODE present? No. And if you see COD, then I will add CLUB. This string is no never present in the list. So since this string is never present in the string, so what I do is I will recur back to this previous function. Okay, now what I do is, since I recur back to the previous function, which already has WE string, since I partition it from this point, now I will do, since I can't find CODE club, this string, this part, okay, I can't find this part partition in the list. So what I do, I will continue my way. Okay, so I will continue my way from WE. Okay, so now I will consider C here. Since I know that I can't find CODE club here, so I will continue my way with this string. Okay, and try to see whether later on it can be in partition such that the partition string should be contained in the list or not. Okay, so now I see that whether WEC is present in the list. Okay, no, it is not present in the list. So I will continue my way. Okay, so now I will consider O also. Okay, the partition is come here. Now I will see whether COD is present in the, whether WECO present in the list. Okay, yeah, WECO is present in the list. Okay, so now I will partition again. Okay, now I will call the function, new function, with which now starts from T. Okay, now like at that time I start from W, then I start from C. Now the same will happen. Okay, now I will start from, now I will take T as account. Okay, this fourth index, I will take fourth index in account. I will try to make this T character substring from this T character. Okay, and I know that the string previously before this T is present in the list. Okay, like before this T is Vico, and this Vico is present in the list. Okay, so let's move forward. Now we'll check whether D is present in the list. Okay, as you can see, there is no words in this string which start from D, so it is obviously that there will be no character. Whether if I fully traverse this string, there will be no character which I mean, there will be no string which will match this string. Okay. So it will move forward and the same process will happen, like we'll check for D, then DE, then DEC, then DCL, then DECLU, then DECLUP. Okay, so no, I can see there is no string which matches this, and after that it will uh, it will totally traverse the string, so it will recur back. Since we can't able to make the partition, since this partition is not present in the list, so we recur back and continue our process. Okay, then again it will continue from Vico. Okay, let me erase this partition. Okay, then Vico, then I will again continue it and it will go Vico. Then whether it is, now I will check whether the Vcode is present in the list. Okay, no, it is not present. Then I will add again E. Now I will check whether Vcode is present in the list. Okay, yeah, I can see that Vcode is present in the list. So again I will partition it. Okay, like partition it. Then now again I will take C as an account. I will try to create C substring. Okay, I will try to create substring starting from C. Okay, now I will check whether C is present in the list. No, it is not present. So I will add L. Whether L is present in the list. Okay, it's not present. So I will add U. Whether U is present in the list. Okay, not. I mean whether CLU is present in the list. No, it is still not present in the list. Then I will add again B. Whether B present in the list? Yeah. I mean whether CLU be present in the list? Yeah, CLU is present in the list. Okay. Now CLUB, I got CLUB also. So it will again go, it will again partition here. Again it will partition and it will go for the next instance, which is the 10th index. And my base condition will be this only. If I encounter my total size, since my total size of the string is 10, so if I encounter any function which gives me 10, which like where I start from my instance. Okay, like here I start from 6, here I start from 0. If there are any function which comes like when I recur the function, if there is any starting point which starts the string from 10, it means the string is totally traverse. And we already find, since we know that since we already know, if I starts from this point, so I know that its previous string is already present in the list. And if I start from 10, which is actually pointing to the null character, so I know that its previous string, like which is v code club, is already present in the list. And it's right, the v code and club is already present in as partition, is already present in the list. So it will return true, and it will reach to this. It also return true, and it will reach to this, and it also return true to me. Okay, so like this brute force approaches work. So let's see how that brute force approach is actually worked. So what first we do is we simply create a function. Okay, which returns a boolean. Let's say the function name is fun, and we pass the string s, the same vector. Okay, let's say wd in short. And where we will start from it, at what position we start from it, let's say it as I. Okay, now the base condition will be as I already see there. If my I is equal to string dot size, if it's total string dot size, if the new instance which I have to create, the sub means at from where I have to start my substring creation, if it's already at the last point of my string, so I know that the previous string, which is actually my whole string, is already been in the list. So it means my whole string is actually present in the list. So I simply return true. Okay, now if it is not, if the base condition is not true, so what I do is I simply start making substring from this point. Okay, I start making substring from this one. Okay, I start from j equal to I, then I will go till the length of the string and j plus plus. And now what I do is I will check at each one, like at here. At first I check for W, then I check for WE, then I check for WEC. Okay, I creating substring from this W, from this zero index. Okay, from the zero index, and this zero index I have W, so I will try to create substring from this W, then WE, WWC. The same I will do in this code. Okay, so I will try to find whether, okay, I will give whole parameter of this list, and what I have to check whether this string substring starting from I, and how much I want, I how much length I want the length j minus I plus 1. Here j minus I plus 1 means the length. This second parameter means indicates the length how much characters I want in my string. Like here it is equivalent to 1, if, because j and I is initially 1. uh, and this first parameter indicates from where I want to start taking my characters. For example, let's say this string here, zeroth index is at points to L. Uh, so I start taking characters from this particular index, and how much character I want? I want one character, since this is equal. If I solve this j minus I plus 1, I will get 1. So I only get the get string as which has one character, so I will simply get here L. Okay. Now if this is present, if this is present in the list, it will simply return me a iterator which points to that particular string. If that particular string, that part is not present in the list, so it will return me the last iterator, which is the which is end iterator of the list. If it does not return me the end iterator, so it means it is actually present in the list. So if that particular string is present in the list, so now I will partition it. The string I'm actually seeing for now, I will try to partition it. For example, we have seen here also, like we get WE, uh, like when we get WE, okay, this string in the list, so we partition it, okay, we partition it from here, and the next we starts from C. Here we start from W, okay, then we partition it and then starts from C, starts to explore the other substring which starts from C. Okay, the same we do here also. We will call the function again, but this time I will start to to make substring from the next index. Okay, next index, and if from that index also I can make partition. It means it return me true. Okay, this base condition become true. And how it is become true, let's say like here, when I make here WeCode and partition it here, so it become club. Okay, I start from this C, then it also get partition. Okay, it also get partition, and club is also present in the list. Then I I simply reach the last index of the string, means total size of the string. It will return me true, then this will also return me true, and this also gives me true. So the same will happen here. If this function returns me true, it means the all the partition happens after this is also actually present in the list. Okay, so I simply return true. And after this all happen, if still this condition does not met, it means there is no possibility, that no possible solution which can be, like there's no partition which can be occur in this string to which can exist in the list which is given here. So I simply return false. Okay, and at last I will call this function. Okay, and 0. So let's see, try to submit it. Okay, begin spelling this. Okay, so there is one more error. This is actually not int, it is actually string, and here it is verdict. Okay, now let's try to run it. So it giving me the right answer. Let's try to submit it. So the brute force approach here gives me TLE, and it's obvious because the time complexity of this code is 2 raised to the power n, and the length of the string is maximum can reaches 1000. So 2 the power 1000 is very large actually. And why it is 2 the power n? It is because I for every index, actually for every character I am exploring all its substring and checking whether the substring is actually present in the list or not. If it is present, then I will explore the next index substring, and it goes on. So that's why the complexity of this code is 2 the power n. Okay, so let's move on to the optimal approach to solve this problem. Okay, so the optimal approach to solve this problem uses BFS, which is breadth first search. It is just like the previous brute force approach we have seen. Just the difference is, let's say in previous when we get WE, okay, when we get WE and it is present in the list. So what we do is we call the function and we do the partition and start exploring the other substring from C. But here what we do is we store the index of this C in our queue, okay, and we say that okay, so save this index, and that I know that this my before the second index, the my string is actually present in the list, okay. So I say that okay, you store this index 2 in my queue and I will explore it later on, but now I will first explore this whole string, okay. So rather than when I get my when I get a substring which is in the list, then exploring the other part, I simply what I do is I will save this other part for later stages to compute. But first what I do is I will check this whole string first. Then I will move to check this. Okay. So here what I do is okay, now again I will check for C and O. Then again I will get this string WCO, which is present in the list, and it is C, and this 3 and then 4. Okay, now I know that before 4 my string is present in the list, so I will store 2. First of all, that my 2 is stored in the queue, then I store 4 in the queue for checking it later on. Then again I will get D, then E, okay, okay, then it is 5, and then again I get 6, okay, that uh, we get partition here also. So then again I will store 6 in my queue, and for so that I can check it later on that okay, so it is also been partitioned. Now see, this whole string is traversed because C, L and U with this is not, this whole string will not present in the list. We get WE, WECO, WECODE. These strings are present in the actually in the list, and its partition, the rest partition is actually saved in the queue. Now I will start exploring the two. Okay, now this like this we move on, okay. This is called breadth first search. At that time what we do is we first go here. If we got any partition, then we simply start exploring the other part. But here what we do is we first complete this first part whole, then move on to the other part to check if I get the answer at first attempt, like maybe this whole WeCode club is actually is in the string, so I don't have to explore this all possibilities. I can simply return true at that time. So this is the first advantage that I got here. And also here I maintain a set which keeps the track whether I have already been to I have already reached to that node previously or not. Let's say I get here 6, okay. So I will put it in my set when I explore my queue. So if any other time if I encounter 6 again, so I don't have to recompute it again because I know that I can't reach, let's say for suppose I can't reach from 16 dash to my result, okay. So if I again reach to sixth index from any means, let's say here, if here I reach 6 from 4, okay, let's say at another time I reach 6 from 5. So at that time I don't have to recompute it because I know already that I don't able to get answer by reaching from 6. So this is another advantage of it. So let's, here is the pseudocode, so let's try to write in it. Okay, okay. So okay, so first we have queue and we have set. First of all I will push, let's create a queue. Okay, let's say it's a queue. First of all I will push 0 in my queue. Okay, so I will have 0 in my queue. Now okay, now I will go to the while loop and I will see whether my queue is empty or not. Okay, I see that and it is not signed. It tells that my queue is actually not empty. If queue dot empty, it will return 0 because my queue is not empty, and then does not sign will invert that 0 to 1, so the condition become true, and now it will move to inside the loop. Now I will extract the first element, which is 0, from the queue. Okay, and now it will be saved in my front. Okay, now I will pop this element from the queue. This element will be popped, and I will check whether this front, which is my, it means my front is 0. Okay, is this front is equal to 0? I mean, now I will check, is this front is in my set. Okay, my set is, you can see my set is initially empty, it is not in my set. So what I do, I will go further. I will not skip this. Okay, there is one more step I have to add here, that I have to insert, I have to insert this in my set. Okay, like I have to insert this, simply assume I have insert this particular front. Okay, if this is not true, so I will go further and insert this element which is in front in my set. Okay, so I will insert 0 in my set. Okay, and now I will move further. Okay, so now this is the same as we have seen previously. I will start exploring all the possibilities. Okay, uh, from starting from this index, particularly front, which is 0, and I will move to the size of this, which is 10, and I will check for each substring whether it is present in the list or not. So you can see for W it is not present, then WE it is present. If this string is present in the list, so what we have to do is we have to push the next index of the string to the queue. It means that this, to before that index my string is actually present in the list. So what I have to do is, uh, I can say that WE at E my index is 1, so I will push 2 in my queue. Okay, so this is my queue and I will push 2 in my queue. Okay, so to the 2 is pushed. Okay, now next time I will go further, then I will get C. Is WEC present in my list? No, it is not present. WECU, okay, now WECU is present in my queue, I mean list. Okay, so now I will push the next element after O in my queue. After O, my next index is 4, so I will push 4 in my queue, and then like this one, DL, WCOD not present, D not present, and E is present. Okay, so after E I have 6, so 6 also push in my queue. Okay, now I don't find any, after this I don't find any string which matches the other strings. Okay, so this process is done. So this whole for loop is run. So now I loop it again, go back to this condition, and is my queue empty? No, I have 2, 4 and 6 element in it. So now it will run, it will get the 2 element, it will get the second index. Okay, in the front I will get it in the front. Okay, now my front is front point to the 2 element. Okay, now I will pop this element. Okay, now I will check whether this 2 is present in my set. No, it is not present in my set, so I will put it in my set. Okay, now the same process will go on. Rather than starting from 2, which we done before, I will start it from 2 to 10. Okay, so what is 2? 2 is my C. So now I will start it from C. Now I will check whether C is present in my list. No, it is not present. Oh, CO not present. COD not present. COD not present. And after that also nothing is present in my list, which is CLU. Okay, so nothing will happen in this condition will never become true. Okay, so my loop will be over, fully read. Now again my while loop will be checked and the condition again become true because my queue is not empty. Okay, so now at the next time my front value will become 4 and this element will be popped from the queue. Okay, so what is at the fourth element? It is D. So I can see that. Okay, again there is no such element which starts from D, so I can simply say it will not, we don't find any, although it will check. Here I will simply, for the sake of simplicity, I will say that okay, since there's no uh, string in the list which starts from D, so it is also does not go in the if condition. The if condition will be true here. So again this whole loop will be run, and again the while condition will be checked. Again my queue is not empty, so again it is true. So now my front will be 6. Okay, and what is at 6 element? It is C. Wait, it is okay. Let me erase it. So it is C. Okay, so is C is present in my list? Okay, it is not. So next time I get L, it will run from, okay, L, let me say it is run from 6 to 10. Okay, so L is not present. Okay, CL not present. Then CLU is also not present. Then CLUB, okay, yeah, CLUB is present. Okay, so CLUB is present. So index after it is 10. Okay, so 10 is put into the queue, but also see 10 is put in the queue, but I have also added one more condition, which is if my I plus 1, which is this, okay, which I add this is my I plus 1. If my index after this particularly string, okay, this is ith index, means it's its last index. If I get this string, if it is equal to my size of the array, okay, my size of the array is n, means it is 10 here. If if I totally reach my last index, okay, last index of my string, which is or you can say the size of my whole string, it means I already traversed the whole string, and I know that after this 10, my string which is formed after this partition, before this partition, is already present in my list. So I can simply say that okay, so the previous string I formed before is actually present in my list, so I can simply return true. But this if after doing this all this calculation, okay, if still I can't able to find any string which satisfy this condition, okay, so I can simply say return false, because there's no such combination I can find that can be partition. Okay, I don't find any partition way through which the partition string is present in all the partition string will be present in my list, so I simply return false. Okay, so let's try to code it. Okay, first of all we make a set. Let's make a unordered set, and then we make a queue. Okay, initially my queue will have a 0 index. Okay, okay, now I will say if my queue is not empty, so I will move further and I will get the first element, the front element from the queue. Okay, and I will pop the front element. Okay, now I will check whether this front element is present in my set or not. Okay, If it is not present in my set, so I can move further. Okay, I can move further, and first of all I will insert this front element. Okay, that I get from the queue. Now I will try to create it, explore its all its substring from this index. The index, okay, the character which is at this front index, I'll try to explore all its substring and find whether any substring is present in my list or not. Okay, so I start from this front, goes till the end of my string. Okay, now I will check whether I can find any string which is present. Okay, let's simply short it first. Okay, now I will check whether I can find any substring which is present in this list or not. Okay, the same I will do sub function starting from front and going till the end. If I find any particular string, okay, which is present in the list, so what I do is I will simply add add the next index of it in the queue, because I know before it the string which I have been formed is already present in my list. Okay, so I will simply add that particular means the string I have got is already present in the list. So for exploring the second part, the next part of the string, I will check the later on. I will check it later on. But first now, I will first explore my current string till the till it's not till it not get null. But okay, but first I will explore the possibility of this particular index. Okay, then I will move on to the next part. But if any times if I get this next element which is equal to the size of the string, means the last ending point of the string, so I can say I got a one possibility of the partition where each partition is present in the list, so I can simply return true. But if this is not true, so I can say that there's no such partition that I can form which satisfy this condition, so I can simply return false. So let's try to run this. Well, I get an error. Okay, one mistake is I actually have to write it here begin. I have write it fine, and also it will does not no, it is not does not it is equal to, because if I don't get that front element in the set, then only I can explore further. If I get that element in the set, so I will not explore it because I already explored it previously. So that doesn't make any sense to explore it again and again. It will just increase my time complexity. Okay, so let's try to run it. Okay, let's give me right answer. Okay, so as you can see, it got submitted. With the time complexity of this code is n squared, because we are traversing the string first of all, and each time we are exploring for each character, we are exploring all its substring and checking whether its partition is actually in the list or not. So it's whole add up to n square, and the space we are using is O of n, as we are creating q and set. Okay, so that's all for today. Hope you understand the approaches that we have discussed, the brute force and the PFS approach. I recommend you to try it on yourself so that you can understand actually how the flow is going on, and you can get the source code link in the description. So I will meet you on the next video. Thank you.